you doing? Monday night, so it is the Physicist and Philosopher Hour. Hello, Dr. Albers. How are you?
Hello, Wayne. I'm very well, thank you. And how are you?
Doing good. I'll have to say it has been rather warm here.
Oh,
This trend that started, Claudia, about, I think it was last fall, it has progressed steadily where we've been 10 to 20 degrees above average. And it seems like we're going to have the same type of summer, which I hate that. I don't like a lot of warm weather at all. How are you on your end?
yeah, I'm well. I'm working on an article right now. I did just putting the finishing touches on it. It's a longish one because I wanted to explain the stellar cores, what they are doing to the Earth. And basically, it explains everything we've been seeing, the sinkholes, the fissures, the ocean recession events. It's all the same thing. And it's all due to the Earth's gravitation is dropping, but it's dropping, it's unstable as well. So it's different for different regions. But what happens is the Earth starts to expand because it's pulling its outer layers with less force than it was before. So you can imagine if you have a sphere and it starts expanding, what's going to happen to that solid surface? It's going to fracture, of course.
Correct.
That's where all the fissures are coming from and all the sinkholes. The Earth's surface is fracturing because it's expanding, because its core is not pulling it inwards with the same force it was before.
So that's a good question. I guess that brings up what is the elasticity of a planet?
Mm-hmm.
I mean, I have never actually pondered that question before. What's its tolerance before it reaches a breaking point in the tensile strength
Well,
of it?
basically, it's a solid crust. So the crust cannot take a lot of expansion. It starts breaking the moment that it starts being pushed outwards. And even the inner layers will start breaking as well. That's where all the earthquakes are coming from. And then as it breaks, you get more fissures all the way to the surface. And what's going to happen is the magma, which is under pressure at the bottom, will start oozing right through all these fractures. So we're going to get lots and lots of volcanic eruptions as a result.
I have been watching on a YouTube channel, Aloha Paradise Tours or something like that. But the young man who is still has access to Leilani Estates. And he has actually, I just want to say hello to all the moderators. Thank you, folks, for coming in. Welcome, everyone, as well. We just appreciate it and hope that you'll find the hour to be at least knowledging, increasing. So getting back to this gentleman, every day he walks to, and he's literally a quarter of a mile, I believe, from fissure number 8. Big Daddy is what they call it. Claudia, I have just never, and I don't think apparently many of the residents there either have, the amount of magma being pushed out of that fissure. And of course, now it's known that the crater, the lava lake, has collapsed. It is now blocked. There was a 5.5 up there yesterday. I think what we're seeing, Claudia, is with fissure number 8, that's the pressure that is building on the main part of the volcano of Maalaea. And then we saw Guatemala, and look how many people died from that.
Yeah, to tell you the truth, Hawaii has become a very dangerous place because this kind of volcanic eruption we are seeing, to me, is a very bad sign. We've had the earth fracturing for years. We've had the ocean recession events. And now we're starting with, because these volcanic eruptions are going to be endless. They're not going to end, because as the earth opens up more and more and more, you're just going to get more and more magma oozing out of every hole. and it's just not going to end. So when it starts at a certain place, it may never stop again.
So when we think about the Earth's crust, we have the mantle, which is what? It's not that deep. I mean, what, 25, 50, 100 miles?
Sure. I can't remember right now. Plus, the last time I looked at it was in kilometers.
Okay.
But I know the crust is about 62 miles deep.
Okay.
And then the mantle will be at least 10 times that.
And that's where the magma is at.
The magma is underneath. Well, part of the mantle, the bottom part of the mantle is also liquid. And then the outer core is completely liquid. And then you have the inner core that's solid.
Okay.
So it's the outer core that's liquid. It's just magma. And it's under pressure because it has all the layers on top of it. So the moment it finds a way up, it will go to the surface. It's just being pushed because it's under pressure. So yeah, with all the fractures, it just finds its way to the surface.
And what did I read? I think it was, I'm trying to think if it was in the New York Times or not, but they have now found a fault line that runs underneath New York City.
Mm-hmm.
And I'm thinking to myself, well, that's a different type of strata. That is much more granite, and those type of quakes would be felt, I think, much more violently than a quake, particularly on the West Coast.
Most likely, but it depends on how deep the earthquake will be.
Right.
Because apparently shallow, close to the surface earthquakes are usually felt much more. And yeah, the granite, in granite regions, usually you don't get as many earthquakes because usually, first of all, you don't get as many fractures because the ground is so much harder. So it doesn't fracture as easily. But the fact that they're finding new fractures all over the place,
yeah, that's just it.
Indicates that they just occurring now. They knew.
Yeah. I used to live in St. Louis and was actually born in Belleville, Illinois. And so everyone is very, very much aware of the what is it?
The San Andreas?
I just had it right there. Maybe someone in the room will catch that. I had it right on the tip of my tongue. You know how that happens, you know?
Yes.
And I can actually, I'm trying to do the recall. What is the fault, folks, along the Mississippi River? The New Madrid.
New Madrid. Oh, yes.
The New Madrid, and the stories of the last big one, which I think was right after the Civil War, where the Mississippi River was flowing backwards.
Oh, yes.
And the riverboat captains were saying that the trees, and these are popular, these are hickory, they were literally, Claudia, being shot up into the air.
Wow.
So when I think about what our country has gone through here in the United States and North America, we've been lullified into thinking that, well, you know, things are just always going to be this way.
Mm-hmm. Yeah, I think the ground there is not as hard. It's not granite. I think it's more like a clay kind of soil.
It's Mississippi mud.
And then what you do is you get liquefaction.
Yes.
And what happens is it just absorbs objects. It's like quicksand.
And they do have quicksand along the Mississippi. I know.
Uh-huh.
I have fallen into it, folks.
Oh, my.
It's not a fun feeling because that sucker will suck you down.
So you can imagine during a large earthquake, the ground everywhere becomes like that. And it can absorb objects, cars, buildings. They just go straight down into the ground.
So I want to get back to what you touched on initially when we were coming here, because you and I have conversed via email, that gravity holes, what I call gravity wells.
Mm-hmm.
It is a theory, but I think that it's one that if you postulate the thought going forward that gravity is not constant,
Mm-hmm.
that gravity can in fact be focused or it can be greatly dispersed into an area.
Yeah.
Is it possible that we could actually experience what they would call gravity voids or gravity wells?
Definitely. Gravity is a lot like electric fields. We can generate electric fields anywhere. All we have to do is charge an object. Well, the gravitational field is basically the same thing. It's also due to particles that have charge. So you can generate the gravitational field anywhere you want. And this is how a lot of the drives that they have, interplanetary drives, work. It just generates a gravitational field. And the gravitational field, I think you mentioned, looks like a toroid. It looks like a toroid because don't forget a photon is actually in the shape of a toroid.
Interesting.
And electromagnetic waves, as they travel through space, are in the shape of toroids. It's one toroid after another after another. That's what an electromagnetic field is. It's a photon regenerating itself right through space, and a photon is in the shape of a toroid. And the gravitational field is in the shape of a toroid. So it's like creating a photon around the ship.
Interesting. You know what got me to think about this, Claudia?
Mm-hmm.
Was watching the, which I guess you could only call it a vol tornado. There was actually a fire tornado at the fountain there at number 8. And it began to get me to thinking. Now, we experience out here dust devils. These are just vortices that the wind is causing by heat and low pressure.
Mm-hmm.
The thought said, well, then why wouldn't gravity have the same effects as well?
Yeah, exactly. If you have what you call a gravity well or a gravitational field, and the stellar cores do that, they have a weak gravitational effect on the Earth, but there's still one. So they have to come very close to the Earth. The same thing will work with a ship that's generating its own gravitational field. It will exert a pull on matter below it. And you then get what you get in reverse when you have a basin with water and a hole at the bottom. What you get is a vortex downwards towards the hole. Why does it move down towards the hole? Because there's a gravitational attraction from that hole on that matter that's above it. So you get a vortex. But now if you have a gravitational field, it's stronger up here than down there, then the vortex works in reverse and it's upwards.
Well, I've seen video, particularly in China, and I believe in India or maybe Pakistan, when it was one of those countries that literally the people were sitting at a red light, the cars were, and the next thing you started seeing were the cars were starting to float upwards.
Yeah, that may have been one of the stellar cores moving over that region. They would do that. Don't forget the connections they make with the sun is in the form of a vortex. They actually pull matter from the sun up towards them, and it vortexes like that, exactly like that. So what they do, they would do the same thing to the Earth. They would come in, they may even come inside the Earth's atmosphere. They just are not ever likely to actually make contact with the surface, because the surface is positively charged and they're positively charged as well, so they will repel. But they are able to come very close and inside the sun's corona, which is the sun's atmosphere. So they may do the same thing with the Earth. They may actually be coming right into the atmosphere or at least touching the atmosphere.
See, I believe that. I believe that there is, I'm getting more and more pictures sent to me, and Claudia, they're just phenomenal. I mean, you can clearly see that there are spherical objects in there. These are not lens flares, lens artifacts. This is clearly catching something.
Definitely. I think they are there, and they've absorbed a lot of energy from the Earth. So they're emitting light, and they're emitting this pink light and this burnt orange light, which you often see in the clouds and cannot possibly be coming from the real sun, because the real sun does not emit those colors. The sun emits white light outside of our atmosphere, and you will look yellow from within the atmosphere. This is the pale yellow. It cannot look pink. It's impossible for the sun to look pink from inside our atmosphere. It has to be.
And you and I, what people don't realize is that you and I have known each other for a number of years.
Mm-hmm.
And we've gone back, and I remember I don't know, I won't call it hysteria, but the excitement, particularly back in 2015, where I think, this is my personal opinion, that we came into the first fringes of this system that I think that we're interacting with. And the evidence in the sky was overwhelming. We were seeing it, as you know, in the magnetopause, through all the satellite telemetry. We experienced what most people don't realize. On June 23rd, we experienced on the planet literally, folks, a magnetic flip. It lasted for 2.5 hours. I still have the telemetry data that shows it. So I don't find this too uncommon, is what I'm trying to say, Claudia. I think what we're seeing is just the increase amount of what we're still yet to encounter.
Yeah, and to tell you the truth, I believe these objects have been here for a very long time. That's why the powers that be have been able to make plans to hide them from us. And they've been here in the solar system for at least 100 years.
I believe that. That I can accept. I don't find that.
This is also why all the planets have been warming up for at least 40 years. All the planets in the solar system, because they go to every single object in the system.
And to bring everyone up to date on this, what was it? I know that it was right after 2010, 2011, that we did begin to pick up background radiation, and it was getting hotter.
Mm-hmm.
And yeah, I look at what's happening, particularly to the gas giants. When we're seeing the perturbations to Pluto, Neptune is just, it seems like Neptune is just going for this rock and roll that it can't figure out where its poles are at.
Yeah, and to tell you the truth, we probably are not being told what's really happening to the gas giants, because these objects are going to rip them apart eventually.
And
destroy them completely. That gaseous atmosphere will be absorbed. It will get heated. It will just, and the gravity will start becoming unstable. And these objects will start losing their gaseous atmosphere and so on. The stellar cores will just rip this atmosphere out of them. That's what eventually happens. And the effects increase very slowly. But I had a breakthrough when I realized that in the sun, we have lots, possibly even thousands of very small stellar cores, planetary sized, or what's left of planets, the core of planets. And there are thousands of them. And there are many large sized. And so I realized that it's not just one system. It's an agglomeration of star systems that the system has absorbed. How has it absorbed? Well, it goes into star system after star system, absorbs all the energy in the star system, basically kills them all because it destroys all the energy. They become stellar cores as well, and then become part of the system, which I started out calling the Planet X system. But basically what it is, it's a destructive mechanism going on in our galaxy, like a cancer, like black holes, but yet are the opposite of the black hole. They absorb all the energy in a star system, destroy all the stars and planets in that star system, absorbs all the energy, absorbs all the objects, and moves on to the next one. And when the energy gets low, instead of how it's opposite to a black hole is that the energy is absorbed and the gravity declines, becomes weak, whilst a black hole, it becomes very strong, infinite. It's actually the opposite of a black hole, but it's doing what black holes do, absorbing all the energy, all the light.
Well, that would kind of go with two things. Number one, in many ancient manuscripts, it's written about the destroyer, which is translated rogue star or rogue planet. Now, today, I'm writing a book, but I came across this. In our galaxy, it is now estimated that there are 50 billion planets. Within that, if you take what most astrophysicists now say is that if 1% of that number, which that is the very minimum, would sustain Earth like planets, that's 500 million planets like Earth out there. Now, I bring this up for the point that rogue stars, rogue planets that are not in a particular orbit, do not have a particular, if it's a star that have planets with it, they may trail them. So here's what I'm trying to say. When we look at the asteroid belt, Claudia, I cannot help but not think that it's happened before. It's most likely going to happen again.
Yeah, I think what happened before was not as bad as what's happening now. Because what happened before could simply have been caused by an object coming through the solar system, but it wasn't a dead object. In other words, it interacted gravitationally in a normal way. And I think it may have been a very large comet.
Interesting. So we would be talking not what most people think are these little fuzzy ice balls, but what I understand there is a thing out there that they now realize are like these mega comets. I mean, big planet-sized comets.
Yeah, but you see, it wasn't a dead object because if this had happened before, if a dead object had come in here, it would have stayed here until all the energy was absorbed by it. It wouldn't have left.
Could that be what Venus is? I mean, Venus does not have...
Venus, I believe, is actually that comet that came into the solar system and may have wreaked havoc.
Thank you.
I think it may have been... and I've written some articles about the fact that star systems can absorb comets and they become planets. It's actually one of the ways that planets form.
I could see that.
Through comet capture.
So you wrote this paper, and I found it fascinating.
Yeah, this was amazing when I discovered what's actually going on and what these stellar cores are. They are, the destroyer that has come, the destroyer of star systems. And this is what we have occurring in our solar system. In a way, it's very scary because there's no end to this. There's no mechanism for them to leave. All they do is destroy everything and then absorb the whole system. It may, however, still take some time. It may take another 100 years for all the energy to be absorbed and all the planets and stars to be completely destroyed in the solar system. But in the meantime, life on Earth will become impossible not many years in the future from what I see happening.
Now, this would be because of what? The sun continuing to diminish?
It's not about the sun. It's about the fact that several of these stellar cores, and I think we have at least 3, possibly more, and they will keep on increasing in number because more and more will keep coming in. They're absorbing all the energy from the Earth. And as they absorb energy, you see in this image, you see one of the larger ones that have come to the sun. You see how huge that is. That object has to be quite close to the sun. So it has to be huge, about 3 times the size of the sun. But don't forget the stellar cores, a star, when it dies, it actually expands in size because its gravity decreases. So as a living object, it may have been a lot smaller. It possibly was a lot smaller than that. But the thing is, the Earth, the problem with Earth is that the object is absorbing energy. As it absorbs more energy, the core, the radioactive decay rate increases, so more energy is generated. So more energy is flowing out through all the layers. It's increasing all the time. So as the objects absorb more and more energy is generated until the Earth runs out of energy or radioactive decay nuclei. When it runs out of these nuclei, it runs out of energy, and then it becomes a stellar core as well. But in the meantime, whilst it still has energy, more and more energy comes out. It comes out through the layers. So more heat passes through the surface. And so the process gets faster and faster and faster. And as that happens, the gravity declines, the Earth expands faster and faster. So it breaks up more and more. So the surface breaks up. And this is a diagram I came up with because there were about 6 that were observed of different sizes. So we know we have about 6 larger ones that were possibly stars of different star systems that was absorbed by the planet X system. And these have come to the sun. They've been observed in the sun's corona. So you can see different sizes.
Well, and I want to say, oddly enough, was reading today on the Kuiper Belt that what we're finding out there as we're learning now what to look for is, I had one of those OMG kind of things, because now they're finding these, I don't know how to describe them. They said that they're large spears that they estimate some could be as big as the Earth's orbit of the sun.
Mm-hmm.
That's huge. But I guess the galaxy is a big place, isn't it?
It is big. Don't forget, I explained what the galactic nucleus is. And the galactic nucleus is basically just a big star. But it's huge. It's like the minimum radius is about 500 AU.
Wow. That's out there.
Yeah, it's like a
if
huge...
you do 90, what is it, 93, 94 million an
yeah,
AU?
I mean, that's five times larger than the solar system.
It's like, man, you're blowing my mind.
Yeah.
Those are like numbers that, quite frankly, it's like our national debt, $21 trillion. What does that mean?
Yeah, the universe is full of extremes. Okay, and then we have the small ones. And this is where I made the connection. Wait a minute, this is not just stars. This is stars and planets in the system. So it absorbs whole systems. The star, or it may have more, it may be a binary system, and all the planets in that system. Mm-hmm. And what we have is these little, it looks like little holes in the corona. And you can see lots, and some of them start emitting light. The they cluster together because you see a bright one in the middle and then 4 around it. So it's a cluster of these objects. And these are basically the stellar core, the planets, planetary cores. That's what's left of these dead planets, or what were once normal planets. That's what's left. They basically lose all their outer layers, and what you're left with is a core with some material around it.
You know, Claudia, what I often think that we sometimes, again, live in this illusion that the universe is somehow in this nice, beautiful, symmetric orbit, and, you know, everything runs just so like clockwork.
Mm-hmm.
It's actually just the opposite. It's a very chaotic, it's chaos. I mean,
it's a very dangerous place.
Yeah, that's a good way of putting it. It's very dangerous.
Yes. And, you know, with the powers that be, they have a real problem now, because every time they work on their interstellar drive, something happens and it fails. So they cannot escape the solar system at the moment. They can go.
Well, that's very interesting, because I don't think people think about escaping. We think about escaping the Earth's atmosphere and gravitational pull, but the sun actually has its solar system. That's a very interesting. I had not pondered that.
Yeah, you need special anti-gravity drives to escape this star system. And without it, you cannot really escape it. And they haven't developed the drives for that.
Interesting.
Yeah.
So what are we looking here?
Okay, so this is some more of these objects. As you can see, the small little ones, they even smaller than the Earth sometimes. And that's a cluster of them. And that's one making its connection to the sun itself. You can
it's like a Birkeland current.
It is like a Birkeland current, exactly, because they make electrical connections. You get everything combined. All the fields are combined in this connection. It's electrical, it's gravitational, and it's magnetic. It's the magnetic interaction aligned with the gravitation and the electric that causes the vortex to occur. That's why there's always a vortex with the gravitational interaction. It's the magnetic force that causes the rotation of the particles.
Interesting. Mm-hmm. Again, we think that because we can't see it with a telescope, or, you know, we can't look at it, and when the sun is, you know, facing us and we're facing the sun, that the brightness of the sun obscures the fact that we have a star field that's just like at nighttime.
Mm-hmm.
So, you know, I argue this in the very early days, and I don't anymore, because it's just, there's nothing to be gained out of it. But the fact is, when you think that when you look up and it's noon, wherever you are, you have to understand there are planets up there, there are stars up there, there's constellations up there that we will never see because we're blocked out of that.
Mm-hmm. Yeah, we in a tiny little island in a very normal galaxy, in a universe that has hundreds of millions of galaxies.
And we get this cockamamie idea, Dr. Albers, at time that, again, that we're seeing this universe. And when you finally wake up to the fact that most of the pictures that you see of the galaxies are still artist renditions. Now, we're getting better with the better telescopes out there. But then again, we're only seeing just a narrow fragment of this galactic core that's huge.
Yeah, we sing very little, and it's very an arrogant attitude to think that we know everything about the universe and it's all this way. This is how it works. But actually, we have the stellar cores that came into our solar system, even though they came to destroy it, and that's a bad thing, they actually showed us that just about all the physics and astronomy we thought was fact was actually wrong. That's what they've shown me. But of course, the powers that be don't want the people on Earth to know the truth about the stellar cores, about the fact that all the physics we've been taught, just about everything is wrong.
You see, that's why I applaud you and honored to call you friend, is that you express so eloquently, I think, that what hinders so many people, that we do not know everything. That which we know today will most be proven wrong tomorrow, which means that if we do not keep an open mind to all possibilities, then we are left with no possible way out.
Mm-hmm.
And when I look at this, we see these things.
This was from 1996. This is LASCO C1.
Mm-hmm.
We stopped working. But as you can see, there were lots and lots of them. You can also see how much larger the corona was then.
Look at this. That is just remarkable.
Yeah. You see the decline in the sun is visible in images like this. And there were thousands of them, because this is seeing them on the side. You see, there were lots and lots of tiny ones. And this is only a sample of what would be there, because we would never be able to see all of them. For example, we'll never be able to see the ones that were in front of the sun. These are only the ones that are on the eastern and western limb and are exactly in the right position in the corona to be made visible. So it's only a small sample of what was there. There must have been thousands of them, and they're most likely still there, except they found ways of, or they took away some of the satellites, so we cannot actually see how many there are.
Hello, Sechi.
Exactly. So this is why the sun has declined so much. So the sun got most of them.
Look at this, folks. And you can just go to, you can go to spaceweather.com, any of the sites out there that'll take you over to SDO. You can see this, that it's, well, I don't know, Claudia, when you look at this, I would say almost a 90% reduction.
Mm-hmm.
Yeah.
And I started looking at photographs taken during eclipses, solar eclipses, and that was the only way that astronomers were able to observe the corona. And the size of the corona was enormous compared to what it is now. And you can actually see over the years, I must write an article on this.
You need to, yeah.
And they started out, they didn't even take photographs, they used to draw them. Draw the corona, and it was huge. And then as the years went by, it got smaller and smaller and smaller. So you can see, I think these objects may have been here for quite a while.
I happen to think that you're correct. What we know about coronal holes, that is a recent discovery. But in the sun itself, our ability to actually look at the sun and study the sun is less than 40 years. Mm-hmm. And we have not gained the knowledge of the universe in 40 years.
That's right. And 40 years ago, the objects were here already.
Yes.
Possibly not as many. So the sun, when we started really observing the sun, we started observing the sun already being affected by these objects.
Interesting.
That dark one there, this would be one of the newer arrivals, because when they arrive, they dark, and then they start absorbing plasma from the sun, and it becomes their own atmosphere, and they start emitting light from this atmosphere, but all at the expense of the sun, all the energy, all the matter. And all the light they emit comes from energy they absorb from the sun. And you can see further up, there's that circular outline. I don't know if you can see it. Yeah, that one there. That one would be an older one. You can see it's also making a connection with the sun, but it's emitting light. That's why it's not as visible, because it has absorbed solar corona, and now it has its own atmosphere. It's emitting light from that atmosphere. But it's still absorbing more energy. They never stop absorbing energy because they like I said, like a black hole. They have no energy and they cannot generate any. So they just absorb and absorb and absorb, and then use it and keep on absorbing and absorbing and absorbing.
So the fourth state of matter is plasma, right?
Mm-hmm.
And isn't it amazing that when you stop and think about it, so little is actually dedicated to the state of plasma?
Mm-hmm.
And
yeah, I know. I can tell you what plasma basically is. It's when you take an atom, and an atom has protons in the nucleus and electrons in the outer layers. When you remove some of these electrons from the outer layers, you get an atom with too few electrons, so it's positively charged, and then a whole lot of free electrons. And then if you have a potential difference across, what happens is the positive ion, which is the atom with too few electrons, moves in one direction, the electrons move in the other. So you have a current. So that's what plasma is. It's called ionized matter. And
ionized matter, that's a good point.
yeah. So it supports the flow of current from one side to the other. And then some of the atoms will be gaining electrons back. And when they gain electrons back, they emit light, photons emitted. So that's why ionized matter emits light. It's from recapture of electrons.
If we could look at, let's take water, and we look at the three states of water, which we're all very familiar with, water would still have then a state in plasma, right?
Yeah, the three normal states are neutral states, where the water molecule, it just has more energy in the gaseous state than it does in the liquid state than it does in the solid state. In other words, in the solid state, the particles are just vibrating. In the liquid state, they're actually moving across each other. In the gaseous state, they're moving all over the place. So they have more energy. But this energy I've discovered is actually photon energy. It's usually called heat, but I actually, after discovering how gravity worked, I realized that photons exist within particles, and that's how heat is generated.
So so cold fusion, that is really what they're trying to see in the process of cold fusion. Wouldn't that be the next state of what I would see hydrogen with two molecules of oxygen?
Yeah, cold fusion is fusion without needing very high temperatures.
Right.
And the way that happens is actually through electricity, because when you apply an electrical potential to plasma, then what happens is you can have certain nuclear reactions occurring, aided by this electrical potential. So you no longer need high temperature. Instead, you need an electric field.
So as you continue to talk, Dr. Albers, what I continue to formulate in my thought process is our solar system continues to interact with this, and I think it is another system. Mm-hmm. And we learn about the stellar cores. And again, for me, it's not that far of a leap for me to perceive the fact that I can't see everything in space. There's just going to be some things that are not going to have emitting light.
Yeah.
But there's still going to be energy.
That's right. The thing is, in the end, everything is photons. Everything comes out of photons. That's why I've written several articles about the fact that we're living in a light universe. Everything comes out of light. But there's only a certain amount of energy that objects are born with. And that's through a radioactive decay. When they run out of that reservoir of energy, they can no longer emit light. And furthermore, they lose the ability to have a gravitational field. The gravitational field drops to almost zero. And then it cannot attract its planets, okay, or its satellites anymore. So it loses them. It cannot attract its own outer layers, so it loses its outer layers. That's how it becomes a dead celestial object.
You know, when you were talking, I was seeing you were describing the life and death process of a body.
That's right.
It's the same principle, isn't it?
Mm-hmm. We are seeing death at the universe level. There is life and death in our universe. Objects are born and objects die.
There's the philosophy, folks, not to cut you off, Dr. Albers, but there's the philosophy, folks, that now begin to perceive and understand that when we look at your solar system that we live in, as Dr. Albers just pointed out here, we're watching a system die. It's our system.
Unfortunately, in this case, but our system is not dying through a natural process. That's what's so bad about it.
It's a cancer, is what you were saying.
It's like a cancer, a disease in our galaxy that's going through the galaxy and destroying star systems before their time. Because our star system would have lived for maybe a few more billion years if it wasn't for the Planet X system coming into it and starting to destroy it and absorb all its energy, all its reservoir of energy. So it's being murdered, basically.
I mean, this is just vampiric all over. I mean, it's just like a succubus. It just sucks the life out of you.
Exactly. This is exactly what happened. So in this diagram, I actually explain how particles come from a photon and how the photon needs to be in an electric field for this to occur. The proton moves in one direction, the electron in the other direction. That's why the photon splits into the particles, because they just torn apart. They inside the photon and they torn apart, and because they are forced to move by the electric field in opposite directions. And that's why a photon splits into these two particles. The particles are inside the photon. They're like energy resonances inside the photon. And that's what particles are. And here I show the process that because the sun and any other object, including a galactic nucleus, has an inner core which is positive and an outer core which is negative, that causes an electric field to be generated, and that's represented by that blue arrow, in the outer layers. And then because of the positive and negative difference, you get a potential difference, which causes discharges, which is the same as lightning in those outer layers. The discharges cause the emission of light, which is photons. And then the photons, as they are emitted and they are moving in that region of high electric field, split into particles. And this is where matter comes from. So when it occurs in a star like the sun, what we get is a CME, or we get the production of solar wind, because the protons are then ejected outwards. That's the solar wind. And the electrons are retained. That's the corona. The corona is mainly electrons, because electrons attract electrons. This is all gravitational interaction. But you can see the two are playing against each other. The electrostatic, which causes the electric field and causes the photons to split into particles, and then the gravitational field acting to generate the electric field and then acting to eject the particles outwards. And so in the sun, we'd have CMEs and solar wind. With a galactic nucleus, you have the same thing, but at a much larger effect. So you get huge amounts of particles, which then condense into cores and then layers around them, and the larger ones become stars and the smaller ones become planets. But they're basically the same thing. They all have cores. They all have unstable nuclei in their cores, and that's the reservoir of energy that will give this object life for billions of years. And this is the representation, illustration of a galactic nucleus, how it ejects new stars along two directions, and that then as they are ejected, they go into orbit around the galactic nucleus. And as more and more are ejected, it actually forms the spiral arms of the galactic nucleus. And then along other directions, we should have returning burnt out stars, which have ended their, by the time they reach there, they should have ended their life cycle. So they're dark. We don't see them coming back. And that's why the spiral seems to end at the edge. That's when the stars die. Because if we were to see them, we would see them forming a whole ellipse. We wouldn't get spiral arms. We get ellipses starting and ending at the galactic nucleus.
And I'm curious on the new stars going out that as they're ejected out, are they ejected out on the ecliptic plane?
Well, yes, it's usually along the plane, the ecliptic plane of the galactic nucleus. That's what generates that plane. It's the fact that they are ejected along those two directions.
Still amazes me, Claudia, when you think of the universe itself, not just our galaxy, but the universe itself seems to be on this ecliptic plane. It's amazing.
It is amazing. And it has to do again with all three forces, because we'd have to include the magnetic force. And the magnetic force is toroidal in shape, and it causes particles to rotate, to spiral. And whenever we have anything that rotates and is spiraling, we see that we have to have the magnetic interaction there. And the magnetic interaction causes objects to have poles, a north and a south pole, and an equator. And therefore, the rotation of objects then conforms to that shape, and it occurs mainly around the equator.
It just fascinates me that we get this. So I have a question for you that someone sent in. So plasma, people are getting reports of what they're seeing as plasma lightning, and then we're getting reports of lightning with no thunder.
Yes, that is, I've got that in my latest article, which it's nearly finished. But what happens is, because there's more energy generation in the Earth's core, because as the stellar cores pull more energy out, the core, as long as it still has a reservoir, just speeds up the generation of energy, because that's the rate of radioactive decay increases in response to the gravitational field dropping in strength. So just more energy comes out, and it goes out through all the layers, through the surface, and including the ionosphere. So it energizes the ionosphere. And when the ionosphere is energized, so it's more charged, then you're going to get increased lightning storms, because there's just more charge up there to power up these discharges from the ionosphere down to the surface.
Claudia, do you think it's that we just have not studied plasma enough, even in our natural environment?
The thing is, Wayne, don't forget that the powers that be have tried for years to stop us from getting the understanding of how the universe works, so we cannot figure out what's affecting our planet. I think they've done that on purpose. That's why we're not supposed to learn about the electric fields in space. We're not supposed to learn about what comets really are, and they are electrical objects. We're not supposed to learn how the sun really works, because the sun is an electrical object as well. And when you figure out how all this works and you see what's happening to our planet, you realize what's actually going on. And they don't want us to know, because they don't want us to realize that our planet's being destroyed. And I think the main thing is they don't want us to turn to God.
Well, no, I mean, that there is absolutely nothing wrong in that approach. I have not a problem with that at all.
It's not just about not panicking, because most of the time they want us to be afraid. They like us to be afraid of certain things.
Mm-hmm.
But they don't want us to know what's really going on and how they are powerless to change it. No matter how much reverse engineering they've done of alien technology, they cannot stop this.
Well, it definitely seems to be on a track that I can't see how we can begin to alter that. I don't know. As we're learning more and more about our solar system, how this thing works, and I think for the most part, and I don't know, this is obviously a layman's opinion, but I think we only know about 1% of the whole big picture.
That's correct. I mean, I have gained a lot of understanding through observing the stellar cores. I cannot say that I understand everything, but it's starting to make sense now what's happening to the Earth. And I started out trying to understand why the sky looked pink at sunset. And I didn't even know it was these stellar cores that were attached to the Earth. I thought they were all attached to the sun in the beginning. So I started understanding more and more of what's going on. And to tell you the truth, it is scary, but it's what's actually happening. It's the truth. People need to know what's really happening. They need to decide what to do about it.
Sure. Yeah.
Because there's nothing much physical we can do about it. Our planet is dying. Our solar system is dying.
I think that's a startling, when we talk about cognitive dissonance, when people really begin to think about it, that the fact that our solar system is in the process of this death dance, that is, some people could say, well, that's the ultimate fear porn, but it could also be the ultimate reality. Correct?
It's true. To me, I mean, when I found out, I was shocked, to tell you the truth. I thought, oh my goodness, is this what's actually happening? Our solar system is being destroyed, and it's going to be absorbed and become a part of this planet X system, which is a destroyer. It's a destroyer of star systems. It will gather all the planets and the sun from our solar system and move on to the next one.
So in this graph here, what I see this is that basically this system is heading for the galactic core.
Yeah, I believe it is. It's not just heading towards the galactic core. It should also spread outwards, I think. But why? Well, first of all, the stars die at the outer edge of the galaxy, and then they should move back in towards the core. So when the first star system died, it would have died at the edge. And then its initial direction would have been to go back towards the galactic nucleus.
Interesting.
Then it could lose its way, because it will no longer be attracted to the galactic nucleus like gravitationally attracted to it. From then on, once it's dead, it's the electrostatic interaction that pulls it in a certain direction.
Sure.
But because the density of star systems towards the galactic nucleus is higher, they're closer together, and also because you get newer star systems closer to the galactic nucleus, then I would expect there's more energy there, and they're attracted to that energy, so they would continue to move towards the galactic nucleus. So I drew it that way.
You know, when I see this too, when I hear you talk, because I can visualize just the density of star systems out here within our galaxy.
Mm-hmm.
And we see it all the time, whether it's with Hubble, whether it's with Cassandra, the rest of them that are now out there, that we're seeing more and more galaxies colliding. And Claudia, when I think about that, I have to step back and say, well, what makes me think that our solar system is so special? We're in this, I don't know, it's like a billiard table. And things do have a tendency to, how shall we say, ricochet, right?
Yeah, that's true.
That's kind of a layman putting it, but that's how the cue ball is going everywhere.
Yeah.
So where are we heading on this as you wrote this paper? And I'm going to stop the share on this. Where do you think that this is all leading for us to?
Like I said, basically our solar system is the next one to be absorbed by the planet X system. In the process, it will be destroyed. Now, it doesn't mean that it will happen immediately. It's a process that takes hundreds, maybe even thousands of years, but it accelerates. And we're at a stage where our planet is being deeply affected. So I think we're in an advanced state already right now. And life on Earth is going to get more and more difficult in a few years. And this system can cause all kinds of things. Like as it gains strength, its gravitational attraction actually increases because it's gaining some energy from the Earth. So we may get a pole shifts. We may, and if that happens, we're going to get enormous earthquakes.
So speaking of this, because you so often, you know, we hear the criticism, but I am like you, they're not telling us anything. So here's, for example, Claudia, this is the deplorable climate warmers that when we look here in the Arctic sea ice in 1971, we look at where it's grown last year, it's actually expanding, not receding.
That's interesting.
Isn't it though? It's because I have heard almost the opposite.
But the thing is, it's not just that, because it seems that when it thaws at certain times of the year, then it reaches much higher temperatures than it should. So what we may be getting is a wild fluctuation.
Oh, I see what you're saying, kind of like the pendulum swinging.
Yeah, I think that may be the case. Or the ice is getting thinner. I've heard that as well, because it breaks up more easily in summer.
Mm-hmm.
Or maybe actually thinner. It may still freeze over in winter, but it's not as dense. It's not as deep.
So the Buford Gyre, the fact that it has this large retention now of very fresh water up here in the Arctic Ocean, that would make sense. Because, you know, non-salinity of water would freeze faster than if you had a saline concentrate.
The thing is, what's obvious is the temperatures at the Arctic are abnormally high.
Yes,
for
they
most
were.
Of the year.
Yes, they
and
are.
I think that's due to the fact that the oceans have warmed up to much higher temperatures than we possibly even being told.
I think I would agree with you. And you know, that's just it. Our planet, I'm living with it here in Denver and I'm seeing it. And I know the folks down to the southwest, I mean, the fires are already starting. It's getting hotter, and I don't like it. I really don't like it at all.
Yeah, it's not nice when it's too hot.
No,
Especially
and
if you are a kind of person who prefers the cold, and obviously you're living there because you do.
I do. I used to live in Texas, and not that I don't like Texas. When I was living in Austin, Claudia, there was only three temperature ranges: hot, hotter, and get the hell out. You know, So, I mean, that's about how warm it would get. I remember one Labor Day, and it got up to like 109 degrees, and I said, you know what? This sucks. I don't care where this job is. I want out of this. Yeah.
Yeah.
And I think about the deaths that we're hearing about in India, Bangladesh, and Pakistan of these intense heat waves. I understand now they're moving into China. And when we begin to see the press who has suppressed this, I mean, when you're getting at temperatures of nearly 126 degrees Fahrenheit, what would that be in Celsius? What would that be? What, 94? 95 Celsius?
No, it's about 40 Celsius.
40 Celsius. Okay.
Yeah, it's about 40, I think.
Yeah. So that's
or more, between 40 and 50. I think that's the temperatures they're getting in India, 40 or 50. But don't forget that, say in the 1980s, it was thought that it was impossible to get a temperature of 50 anywhere on Earth.
Yes. Okay.
So these are abnormally high, but this is only because the heat is coming out from the interior of the Earth.
I was going to ask, so where is this? Because it seems to be concentrated. It seems to be, and Claudia, I don't know. I haven't seen any studies, but I bet you if we were able to get the data, I bet you it's spherical in its influence, as opposed to an erratic type of border. So where is it coming from?
You see, the Earth itself is generating more heat, the core, because as the stellar cores draw energy, and heat is energy, the Earth just generates more heat.
Okay.
So the heat is flowing out from the core through all Earth's layers outwards, and then it's being radiated. It's energy, and therefore light. Heat and energy is all light, is being radiated by the surface of the Earth out to the atmosphere.
Claudia, could we be seeing the effects of plasma as well in these isolated incidences that somehow or another?
We are basically, everything is electrical to one degree or another. So even though the Earth's atmosphere is mainly neutral, you still get plasma, at least when you have lightning, because there is an electric potential difference between the surface of the Earth and the outer layer, the ionosphere. And so you're going to get atoms being ionized because of this potential difference. So, and inside the Earth, we have the same thing, because the core, this potential difference actually between the core and the outer layer. So you get ion, and then you have all this heat in the inner core, which helps it. So there's ionization everywhere. And earthquakes are actually electrical in nature.
Yes.
And that tells you as well, because the ionosphere can affect the inner planet by inducing currents inside. And these electrical fields and these electrical currents will lead to earthquakes occurring. So all phenomena, all mechanisms that are occurring in the universe are due to electrical interactions. Or we can think of them as gravitational, but it's actually the electrical that gives rise to the gravitational interaction. You do not get one without the other.
I was going to say there would have to be an electromagnetic field involved.
Yes.
Yeah. Now I'm beginning to understand more and more about what Tesla was looking at. What you're describing, you're teaching me, but that allows me now to begin to comprehend much more when we begin to think about the core of the Earth having a greater influence than what we ever thought on the surface, because we always think that it's coming from the atmosphere down.
Well, some of
You're
it,
a smart lady. I don't know if anyone ever told you that before.
thank you. Some things are coming from outside, but most of the energy powering the Earth's mechanisms is coming from the Earth's core itself.
Yeah. Yeah. This is radical. It's a radical new approach that begins for a layman as myself, that, yeah, and this is why I enjoy our shows, that it adds to my knowledge, and that is where we begin to increase in wisdom.
Yeah, and you mentioned Tesla. What Tesla discovered was that there was a potential difference between the surface and the ionosphere. And he realized he could use that as a source of energy, as a possibility for communication across the planet. That's what he discovered. And that's what the powers that be didn't want us to discover.
Yes, and now you can actually conduct some of his experiments that where we can actually get a Tesla coil, and you can buy them. And the point that obviously have someone who knows how to use it, but we now understand how he was the transference of free electricity, was that he was using the Earth as a conduit and then connecting into the atmosphere. It's fascinating.
Yeah, well, the Earth is an electrical conductor.
It's amazing.
Yes.
Oh, Claudia, this is, listen, do you have a couple or more minutes? I want to show you some pictures that I took today, but I wanted to show you as well. Let me pull this up. So it's nice when we get confirmation from other subscribers and viewers. So this was my house on Saturday. This is like really high up in the atmosphere. I can actually catch the International Space Station, Claudia, in the middle of the day.
Wow.
I've actually caught it twice now. So I saw this, and on Saturday here in Denver, Colorado, it was beautiful. 72 degrees, wasn't a cloud in the sky. This object came out of the northwest, and I want to show you this because you're going to be surprised when you actually see the other footage, if I can ever find what I did with him. Where did he go? There he is.
Oh, there it is.
Yeah.
Oh, look at that. It's got two trails behind it.
So this is a high altitude craft. This is actually up in outer space. It's up in the even the International Space Station is not in outer space. It's up in the upper atmosphere. But I want to show you what happens. So you don't think anything's happened, right? But when you look at this picture here, look what's trailing. You see them?
Oh, yes.
Yes.
And they don't look like normal planes at all, do they? No,
and look at our little friend here.
Oh, my goodness.
So I actually went in.
It's triangular.
It is. Look at this right here. Now, I had a subscriber who, look at that, Claudia. And just for the fun of it, went ahead and put it in the X-ray, infrared, excuse me. And look at what we have here. It's, there you go. Look at this object.
That one looks rectangular.
It does. And I almost think that I think what we're seeing is the wings on this, but this is a very strange craft up here.
Very strange indeed.
So I actually had a subscriber send me, and this is what we do here is that I took the gamma and the saturation up, and this shows us what is really up there. And there it is.
Wow.
This thing is really high. And so
this is actually a spacecraft because it's so high up in the atmosphere.
So this is a viewer who is here in, I forget what part of the country, but you're going to see, da-da-da-dum.
Oh.
There it is.
It looks extremely bright.
Yeah, this is just in a different direction that this craft is going, but here it is, and you really get this craft. Look at that.
Yeah. When I see objects that are this bright, it reminds me of one that I saw that was clearly had a field around it, and I could see it had cloaking capabilities.
Yes.
That's what this field but it was malfunctioning at the time, so you could see it was a chaotic state, that the field like whizzing around the object. Yeah.
I think
that's amazing.
I think we're seeing this. Yeah, someone and I happen to think to agree. I looked at some of here in Denver, we're right over what they call the footprint. So I get the ISS regularly here, Claudia. It comes over sometimes 4 or 5 times in a day. And just because where we are. And I believe that this is the X-37. I think this is the craft that NASA has been testing. And I think we just happen to be in the flight path.
Well, the Aurora program is actually very old.
Yes.
So it may actually be a more advanced one that they're testing now.
Good point.
I don't know.
So you can see the similarities, and the UFO here, it clearly came in. So I just wanted to, I know you and Scott have been seeing a lot. I know that there have been others as well that have seen it. So just thought you
these are fun, to look at.
They are.
Yeah, I enjoy that.
It's like, well, we'll have some more next week. We're getting a lot of the subscribers sending in pictures, and so they want you to take a look at them, and maybe we'll have some carve out some time and do analysis.
Yeah,
I'll tell you, one in particular that I sent in today clearly caught a planet. I mean, it's just as plain as in your face, and so we'll pull them up, and I'll just put them in a file for us.
Yes, that sounds good.
Well, all right. So folks, we went way over, didn't mean to do that, but I got to tell you, Claudia, when you're teaching, it's just like in a classroom. It becomes very, it pulls me in, and this is what I enjoy it.
Thank you, Wayne. And I love teaching. I'm actually a teacher at heart. I enjoy teaching. I enjoy interacting with my students. I was the sort of lecturer that came into a classroom and I would start teaching, and I could sense, are the students aren't they understanding? And it was just this connection between me and my students. I just had an intuitive feel about what they were understand, they were not. And I enjoyed that. I enjoyed sensing people's interest. Do you know what I did when they lost their interest and they started talking? I would get quieter. And I would say, well, in the next exam, telling them what they were expected to learn for the next exam. And they would all go, shh, shh.
Well, you have a classroom here of nearly 300 students. So, and send if you have questions. Now, I do forward the questions off to Dr. Albers. So if you have them, a lot of them are very, very bright questions. I just go, amazing group of people. So thank you. And Dr. Albers, until we meet again next Monday night, thank you. Keep yourself well. Keep on writing because I enjoy it. And I know everyone else here does as well. Give Scott my best. And when you see him again, and everyone, thank you again. Thank you to all of the moderators. We appreciate you coming in. We know you got other places you could go, but we thank you that you would spend your time here with us. And
thank you.
Dr. Albers, again, just a pleasure and an honor. All right, folks, we'll see you probably tomorrow, definitely on Wednesday. I'm going to try to get Tricia back on. And then Wednesday night, I'm going to have Brian and Sue G on. So there you go, folks. Make sure to subscribe over to Dr. Albers' channel. It's linked below. Her books are linked as well over to Amazon. So thank you all. Moderators, much love to you all. So keep yourself safe, folks. We'll see you the next time I'm online.